Hello, everyone. Welcome to our session for scaling AI development with software template in Backstage. Before we get started, let's introduce ourselves a little bit. So my name is Elson Yuen. I'm the architect for the AI and plugins in Red Hat Developer Hubs, which is built based on Backstage.
Hi, everyone. I'm Maysun. I'm an engineer at Red Hat, and I'm also working with Elson on software templates for Backstage and Developer Hub.
Okay, so what are we going to go through today is we are going to give you a quick introduction on the AI software template, and then we'll go through the template architecture. After that, we'll talk about the model integration strategy that we have for our template. To spice things up, of course, we will be doing a demo because otherwise it will be too boring for it. And then we will be talking about some of the challenges that we have seen when we are doing the software template as well. So why do we want to create the software template in the first place? It's a predefined blueprint that allows us to create new software components, services, and applications. So by automating this initial setup process, we ensure every new project starts with ready-to-use, standardized resources to be in place. So what's special about AI application development? So the LLM and the model servers are constantly changing. As you know, new models and servers always get popping out all the time. You don't know which one is good, which one is not good. So using these templates allows us to abstract the complexity out so that we can instantly get the updates that is compatible to your application. And then when we update the new LLM and model servers, you automatically get those for free. So what does it mean? Like, what is the benefit of that? What it means is the automated boilerplate setup. Developers can focus on building their applications and features, not on configuring their projects. With the golden path, it ensures every service is built and deployed in the same way as well. By providing the best practices, and we also embed all the security, observability, and also testing in the code. It ensures every new project is automatically meeting the compliance and standards for the organization. So one of the things that we have heard in the past is, companies and organizations are actually really conscious about what type of models that developers are actually using because of security reasons. So with these software templates, you ensure the models that the developers are using are actually approved by your organization as well. Our plug-and-play approach decouples the applications with the LLM. So by using a template as the abstraction layer, teams can easily evaluate, swap, or plug in their models with minimum code changes. So let's talk about the template architecture itself. When we take a look at different setups, we find there are three main core building blocks that AI applications has. The first one is, of course, your AI application itself. It's the applications that you're developing. We use Streamlit as the front end, and then for our different AI use cases. And we also use some applications from Podman AI recipes as well. The second is the pipeline. Pipeline is a standardized CI/CD pipeline that scaffolds for building, testing, and also deploying your applications. We are using Teton pipeline for that. The third piece is the GitOps, which is more dealing with the deployment. Argo CD applications, customized overlays, provides us to allow us to do environment-specific deployments. Note that Streamlit, Podman AI recipes, Teton pipelines, and Argo CD, all these are technology of our choices. By using the same type of modularized design, you can easily replace it with the pipeline and the GitOps of your choice. So let's see how we can bring all those three components together to build our centralized software template. So each of those yellow blocks at the top are stored in its own GitOps repository so that you can develop them and also version control them individually. And we use something like an assembly line to combine all three of them together with a core template skeleton. Template skeleton is like the master file for a template. And based on simple property files for configuration, it compiles and customizes them into specific templates that they're ready to use, and then they have specific purpose. And those are the green blocks at the bottom. So take two of the template samples that we have. The chatbot and the code-gen templates share the same core skeleton, but because of the properties that they have different LLM and model servers bootstrapped. For example, the chatbot template is using Granite 3.1 with Llama CPP, and then the code-gen is using the Mistral and also VLLM. So this module design gives us excellent version control that simplifies the dependencies to ensure what we produce and enable to stable and reusable and also easily maintainable templates. So now that we have gone through the architecture for it, let's talk about our model integration strategy. I'll pass on to Maysun for that.
Thank you, Elson. So now that we have our templates, we're going to talk about how we went through our different strategies to integrate the different models and model runtimes with the software templates. So in the next few slides, I will go through each of them and give you an example as well as a demo. So the first one is the starter models. So in this strategy, we have bootstrapped the model runtime and the LLM with the software templates. The advantage with this approach is that developers can quickly get prototyping with their applications, and they can easily onboard with minimal configuration from their side. So you just go through the software template creation process, create a component with minimal user input, and you have a model runtime and a model that's up and running, and you can use your application with it. So as you can see from the GIF over here, I'm simply choosing a model runtime, like let's say Llama CPP and the Granite model that comes bootstrapped with this specific software template. Now, as we iterated through this approach, we found that there were few stuff that we had to overcome. First and foremost, we had to create our own custom images. And the reason why we did that is because we wanted to optimize the image for being lightweight, as well as customizing the images so that we can run them on OpenShift, because that's what we wanted to deploy on. Now, there were certain pain points when we approached this strategy. First and foremost being, as you might be aware, the AI landscape is pretty quickly changing rapidly. Every cycle, every month, we have new releases, new breakages, new evolutions of technologies, and that means constantly updating your image, constantly updating your tech, and that meant always keeping up pace with the industry. And of course, that leads to a dependency nightmare. If I want to update my model runtime image, but the latest model runtime does not support the model of my choice. So you create all these dependency nightmares that we had to go through. And of course, all these images means they are pretty bulky, and creating bulky images means taking a lot of your developers' time, taking a lot of your CI/CD capacity, and always being backlogged with recent updates. Of course, we tried to improve these pain points using Renovate by updating our image automatically, but still a work in progress. And that leads us to our next strategy, where we ask the developers to bring their own models. So in this software template strategy, you can see from the GIF that we say, hey, developers, why don't you provide your model server endpoint and the model that's deployed on it? So in this way, the developer can integrate any third-party model that they wish, and it fosters innovation and experimentation. A developer can try out new models with their AI applications, and you don't have to restrict yourself with the bootstrapped or the default model or model runtime that comes with software templates. So here it's an example where we have a template, and I'm just selecting bring your own model, provide the URL to the model endpoint that's deployed externally, and I just specify, oh, this is the model that's running on that endpoint. Now the third strategy is the Backstage catalog. In this catalog approach, this is primarily used for production environments, and this lets us decouple the models from the templates. You have your platform engineers and your developers owning the models and the curated list. The platform engineers can have a list that meets the company's or your organization's policies when it comes to security and other compliance. So it's a pretty neat way to think about integrating your LLMs with your software template. And of course, you're not restricted to a particular LLM when it comes to integrating it with your application. So here in the GIF, you can see that I am choosing the option, choose from the catalog model. And in the dropdown, I have the Granite model. Now, this particular Granite model is actually coming from my Backstage catalog, and I am bringing it to my Backstage catalog from my model registry of choice. So you can have your Hugging Face, you can have your other model registry, and we use a plugin that brings the model from the model registry onto the Backstage catalog, and then the software template can use that model. So let me quickly show a demo of all these three use cases. So here I have a list of all the software templates that is on my Backstage. And you can see that I have tech docs associated with all these software templates. These tech docs go through the process of the prerequisites and what to do after you deploy your application. Now I'm going to launch this template we're using for our demo today. I'm going to give it a name, and I'll keep the Argo CD information as it is. As for the model runtime, you can see from the dropdown, I have my three strategies. The first couple are VLLM and Llama CPP, which are bootstrapped. And then you can bring your own model server, or you can choose from the catalog model. So for this one, I'm going to just select Llama CPP and the Granite model that comes with it. I'm going to create my application on my GitHub repository. I give it an organization name. I give it a repository name. And I go to the next page where I give the deployment information. I give the Quay.io default image registry, give it an image name, and I also change the deployment namespace where my workload will be running on. I also have the option to create a workbench for OpenShift AI, which I will show in the next few minutes. So I reviewed my information, and I click Create. As the component is created, of course, I have my topology view, where I can see my deployments, and my CI view, where I have a couple of pipeline runs for push and pull request events. So these are all the pipeline runs running against my application code. And I have my GitHub repository for my application, for my AI application. And I can see my pipeline running here. And this GitHub repository is for my GitOps, where I have my deployments for my application and the model server itself. Once the pipeline is complete, they are all green in color. I go back to my GitOps, I refresh, and I see that there's a new commit there. I go check out what the commit is, and I can see that the deployment patch container image has been updated with the new image. Now I go back to topology, and I launch the application, and I can see that the application is up and running. So I quickly test it out to see if it's working. There you go, it is working. I wait for a response. Perfect. So in the second strategy, I'm going to bring the model server deployed externally, and I'm going to specify an endpoint URL where it's deployed. So this is the URL that's deployed externally. And I'm also going to specify the model name that's deployed on that endpoint. I have the option to authenticate the endpoint if I need security. Here, I'm going to create a workbench for OpenShift AI. This is the exact same process as the previous one, so I'm not going to bore you with all the details. But in the third step, where I'm going to use the Backstage catalog, so this is OpenShift AI, I have a model catalog. Here, I have a list of all the LLMs that I have available to me on this catalog. And I have the model deployment over here. So you can see that I have a Granite model up and running. Now I'm going to bring it to my Backstage catalog using a Backstage plugin. So I go to resource kind, and I filter, use the type filter, and I select AI model. And I can see the Granite model available to me on Backstage that has been bridged from the model registry. Now I go to my template again, and here I choose the third option, choose from the catalog model. When I use the dropdown, I can see my Granite model available here. So this is the model coming from my Backstage catalog that I bridged from the model registry. Of course, you can authenticate again if you want that. I'm not doing it right now. And so here in my OpenShift AI, I'm going back to the data science project section. If you remember the second approach, I created a workbench. So here, I have the workbench up and running. It's called a notebook. So I launch this notebook, and I have my application where I can list it and pip install and run the Streamlit application. I can then port forward the pod to my local host, and I can also see it running on my local host browser. That was a quick demo. So of course, the demo was on Developer Hub, which is Backstage, but it is an enterprise version. And as we were iterating and developing the software templates, we did come across certain challenges and roadblocks. First and foremost, in terms of user experience, we found out that the different model strategies that we used was kind of confusing for some folks, our users, because when folks were selecting the model runtime, the field labels didn't update, and they were left confused what to do. So we did kind of work around it by approaching it in a hacky way. Nevertheless, the second problem that we faced was no environment awareness. So if you remember, in my demo, I had the option to create a workbench on OpenShift AI. The issue is, what happens if OpenShift AI is not installed? During runtime, as you're creating a component from the software template, we don't have awareness of what platform or technologies is installed. So if OpenShift AI was not installed and you just selected create a workbench on OpenShift AI, it would lead to failures. So these were some of the issues that our customers or our users faced and we faced, and we're trying to approach it. It's still a work in progress as we move along. So those were some of the strategies and iterations we did when drafting software templates. I'm going to pass on to my co-speaker, Elson, to close things off.
Okay, thank you, Maysun, for doing the demo. It's great. So in case you want to reproduce what we just showed on the demo, we include our software template repository in there, and also the 3 building block separately versioned repositories in there as well, so that you can reproduce what we actually showed today, except the minor pieces, which is like the create OpenShift AI workbench, for which that one, of course, require OpenShift AI on that, but other than that, you can reproduce most of the stuff in there. And also, we include a repository, which is we are doing model catalog bridge, for which we are doing how we actually model the AI models in the catalog in Backstage. And also, there are a couple of blogs that two of them are actually brand new that we just released today, in case you're interested in more read-up on AI-related technologies. First one is around the software template that we talked about today, but then we also have the catalog of the AI asset that you can follow through and go through what we can do for when we're doing the modeling on the catalog. And we also have some MCP tools for which we have recently created, and we are also planning to donate some of those MCP tools in Backstage as well. Okay, so I think we've got some time for a little bit of Q&A in case you have any questions. Okay, if no questions, so what we have done in this session is we talk about the benefit and architecture of the software templates. We also go through the model integration strategy as well. And also, of course, we do the demo and seeing the templates live in action. Now, if you have any questions or comments, feel free to ask Maysun and I on that. Your feedback is really important to us. So there's a QR code up there in case you want to leave us some feedback on this session. Feel free to do so. And we really enjoyed sharing this presentation to you. I hope you enjoyed this one too. Thank you, everyone.
Thank you.